In our previous lessons, we've added and subtracted by writing a whole bunch of positives or a whole bunch of negatives, circling zero pairs, and then counting what's left. This works great for small numbers, but if we have big numbers like 576, nobody wants to write out 576 positives or negatives. So what we're going to be doing when we're working with multi-digit numbers, and especially with decimals, is we're going to be using some features of our place value system to make our calculations a lot more efficient. And what place value means is it means that what this number represents is different based on where it is placed. So that this number right here is not 5 ones, it's 5 hundreds, because that is in the place that it's in. So whenever we have this number, if we're representing it with positives and negatives, we can actually make a little chart and say, okay, we're counting how many hundreds we have. So this is called a place value chart. In this first number, I have 5 hundreds. The next place value over is tens. So I see I have 7 tens. The next place value is ones. I have 6 ones. After that is my decimal. Next up is tenths. I see I also have 6 tenths, 1, 2, 3, 4, 5, 6, and then hundredths. I have 3 hundredths. So what this diagram lets me do is it lets me draw out my pluses and minuses much more concisely, or with many fewer symbols. Instead of writing 500 little pluses, I write 5 pluses in the hundreds column. Now when I go to add, I can look over at this 17.1 and I just put those in their correct column. So this tells me I have 1 10, so I'm going to add 1 more to the tens column. This 7 tells me I have 7 more ones, 1, 2, 3, 4, 5, 6, 7. And this 1 tells me I have 1 more tenth. Now to figure out what I have total, I can just add up all the pluses and minuses that I see, just pluses in this case. 3 hundredths, 1, 2, 3, 4, 5, 6, 7 tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 ones. Ooh, now I have a problem. There's only one space for me to write how many ones I have, but I have 13 of them, and 13 is 2 digits. So this is where regrouping comes in, or carrying, as you know when you do standard algorithm. Every time I have 10 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those get regrouped and turned into 1 in the next column. So that means I really just have my 3 ones left over right here. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 tens, and 1, 2, 3, 4, 5 hundreds, for an answer of 593.73. And now many of you know how to do this with the standard algorithm. So that would be 576.63 plus 17.1. Add those up. 3, 7, 6 plus 7 is 13. Carry the 1, 9, 593, you get the same thing. Notice that right here, the carry the 1 that you have right here, that's the same thing as this regrouping of 10 ones into 110 that happened right here. And it's totally fine if you are comfortable doing this way and you want to do it this way to show work, that's totally fine. The reason that I'm explaining this to you is because our objective is for everyone to be able to add and subtract all decimals. So if this way doesn't make sense for someone, I want you to have a second way that you can explain it. Also, as we're about to see with these ones, there are some times where what to do with the standard algorithm isn't immediately obvious. And so I want you to have a second way where you can understand and draw out what's actually going on so that you can do problems that are more complicated. Either way, though, is going to give you the same answer. So let's take a look then at this. Remember, whenever we are doing subtraction, we always want to write that as adding the opposite. So this is really 23.4 plus negative 8.3. And whenever I have numbers that have different signs, so 23.4 is positive, 8.3 is negative, I'm going to look for which one has the absolute value. Which one do I have more whatevers, whether they're positives or negatives, that I'm going to draw. And in this case, this is 23.4. So I'm going to start with putting 23.4 in my chart. So I've got my tens, there are 2 of them, 2 positives. I've got ones, there are 3 positives. I've got tenths. There are 4 of those. 1, 2, 3, 4. Now I'm going to add my 8.3 negatives. That's 8 negatives here, 8 negative ones. 1, 2, 3, 4, 5, 6, 7, 8. That's 3 negative tenths. And now I can just make 0 pairs like I always have. The key thing is that because I am starting with more positives than I have negatives, we can see I've got 2 positive tens and no negative tens at all, I know that my answer is going to be a positive number. So that means that what I have left over in each of my columns should always be a positive number. And that's not a problem over here. These make 0 pairs, but I have 1 left. But it is a problem here. 1, 2, 3. I have these negatives left over when I know my answer is going to be positive. So this is a different type of regrouping. I need more positives in this column, so I borrow one of the positives from here and break it into 10 ones. So that gives me more 0 pairs. Ooh, I'll get that one. 1, 2, 3, 4, 5 positives left over, and then 1 10 left over. So I have 15.1 as my final answer. And for those of you who are comfortable with the standard algorithm, that looks like this: 23.4 minus 8.3. 4 minus 3 is 1, but I need to borrow in order to subtract this 8. So 13 minus 8 is 5, and 1 minus 0 is 15. It's the same thing either way. Where the chart really comes in handy, though, is for something like this, where what to do with the standard algorithm isn't at all obvious. So the key thing to first do is to first write this as adding the opposite. So this is plus negative 3.54. And then we look at this, and when we go to make our chart, are we going to have more positives or are we going to have more negatives? Well, we can see that we have 3 negative ones and no positive ones, so we're going to have more negatives. So I'm going to put the negatives into the chart first. So here's the ones, I've got 3 negatives. Here's the tenths, I've got 5 negatives. And here's the hundredths, I've got 4 negative hundredths. Now I can go and I can add. There are 0 positive ones, 2 positive tenths, 6 positive hundredths. Now, because I've got more negatives than I do positives, I know my answer is going to be negative. So that means that all of my columns, I should have negatives left over. Here are some 0 pairs. And oops, I don't have enough negatives. So I'm going to go over, I'm going to borrow one of these negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I can see I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 negatives left there. Here's some 0 pairs. I've got 2 negatives left there. I've got 3 negatives left there. Negative 3.28 is my answer there. If you see how to do that one with the standard algorithm, that's super spiffy. Let me know while you go around and work on it.